Bismillahirrahmanirrahim. Today I am going to start a new topic, that is ionic liquids, what they really are, how they are produced, how they are synthesized, what are their applications, what are their advantages over the other liquids. So this will be the topic of the discussion. And secondly, we will also look into their uh, applications, especially recent developments in the field of the application of the ionic liquids, that I will explain to you inshallah in my next lecture. Today I am going to introduce what are the ionic liquids. They are supposed to be liquids at usually room temperature. They are liquids usually at room temperature. That is why they are called ionic liquids. Let's see, we have an idea about the salts. Like sodium chloride, we have an idea about sodium hydroxides. They are the ions, ionic compounds. But generally they are solids. Generally they are solids. However, the ionic liquids are supposed to be the ionic compounds, but they are supposed to be liquids at room temperature. Secondly, they are stable over a wide range of temperature. Over a wide range of temperature, they are supposed to be stable. Wide range means, let's say, at least from 300 to 400 degrees centigrade, they are stable. They won't undergo any sort of decomposition. They will remain in their ionic form. They will be stable. There won't be any chemical change. There won't be any change in their structure. So they are supposed to be stable over a wide range of temperature, and this property is called thermostability. Thermostability means they are stable over a longer range of temperature, like 300 to 400 degrees centigrade. Secondly, as I have told you, they remain in the form of ions, ionic liquids. They are in the form of ions and also in the form of liquids. No change in their physical state. So they are also called as electrically stable as well. Thermostability are thermostable, and they are also electrically stable. Electrostability is also there, means they won't decompose. No change in their physical state, no change in chemical structure. So they are thermally stable, they are physically stable over a wide range of temperature, like 300 to 400 degree. In case of the other solids, like sodium hydroxide, I've given you example over here, or sodium chloride, they are supposed to be generally solids at room temperature. Like sodium chloride, it's a solid and its melting point is generally about, I think, 800 degrees centigrade. The melting point is supposed to be, just check that out please. Secondly, if we see any ionic liquid like this one. It's a structure of an ionic liquid, imidazole. This is called an imidazole, and then it will called as imidazolium. That's a chloride. It's a sort of ionic liquid, and it's if it has like PF6 over here minus, its melting point I think is -8 degrees C. So you can see the hell of the difference between the two. It's an ionic liquid at the room temperature, and it is supposed to be solid and have a melting point of 800 degree. So this is one of the example of ionic liquid. How they are produced, what is the name, what are the anions, what are the cations actually. I'm to explain it next now. So this is one of the example where I just want to give you the idea about the difference in their melting points, about their presence of as liquids at room temperature and its presence as solid at room temperature. As they are liquids at room temperature and can withstand a wide range of temperature, so they are thermally and electrically stable liquid, so they could be used as solvents. As you know, we use solvents for the chemical reaction. We use solvents for the chemical reactions. Sometimes, quite often, we do heat our reactions as well. Sometimes we heat over 100 degree for longer period of time, 12 or 18 or 24 or something like that. So in such cases, this sort of compounds, these are liquids which are stable over a longer range of a temperature, they are preferred as solvents. I will discuss it thoroughly when I will be discussing the applications of ionic liquids. As I've told you, as in case of ionic solids, a cation and anion is there. Similarly, in case of ionic liquids, there is also a cation, there is also an anion. Okay. Chemistry of cations and anions. Chemistry of cations and anions influence or impacts, better to write control. Anions control the thermal and electrical stability. What is the nature of cation? Whether it's a longer sort of organic compound, or it's a sort of a smaller, it's a sort of a heterocyclic compound, it's a sort of a carbocycle, so it matters. It also, in case of anions, I've given a PF6, it is something like that, PF6. This is anion. Okay, so these two make an ionic liquid. It's an anion. Similarly, it would have also been replaced. Someone can, as I've written right in the beginning, someone can use simply chloride over here as a negative. So that was also a ionic liquid. However, ionic liquid with the chloride and the ionic liquid with PF6. both will have a hell of a differences in their stability, in their electrical properties, similarly in their solvating properties, their properties as solutions, their properties as solvents. So all properties do controlled by the chemistry, mean nature of the anions and cations. Actually, what will be the chemistry, what will be the nature of the cation, or will be the nature of the anion, that will control the overall properties. I am to explain it further. Till to date, at least more than 300 ionic liquids are commercially available. You can imagine the importance of the ionic liquids. One can imagine, the uh, applications. One can imagine their attractive properties. At least 300 different types of ionic liquids are commercially available in the market, which could be used in different ways in variety of reactions, as catalyst, as solvents, for energy purposes, in batteries, in fuel cell. This and that will be discussed later. So this is how they are supposed to be. To give you a bit glimpse of about their uh, structures. So if it's a sort of a compound starting from imidazole, we have an idea this is an imidazole, 5-membered ring containing 2 nitrogen. I'm talking about the cations now, the variety of cations that could be used, and they are organic cations. The cations could be organic as well as inorganic. Few of the options available are imidazolium. Imidazolium, and depending upon the nature of the substituents, whether they are simple alkyl substituents or some sort of an aromatics, the name will carry the same um, alkyls or aromatic names in the main name of the ionic liquid. Similarly, this is called very famous benzenes, one of the carbon when it is replaced by nitrogen, it is called pyridine. Okay, so if this pyridine gets substituted with another substituent, the nitrogen will carry a positive charge, so it will become a cation, so it will be pyridinium. It can be called as a pyridinium. Similarly, you would have known about a 5-membered ring carrying 1 nitrogen. This is called pyrrolidine. Generally, it carries 1 substituent. If it carries 2 substituents, subsequently the nitrogen will have positive charge, so it will be called as pyrrolidinium. Okay, so these are the few examples which I'm trying to give you. Few examples of the organic cations which could be used for the preparation of ionic liquids. You can start having imidazolium as your cation. You can bring in any anion. that will be a one of the ionic liquid. Secondly, you can go for the pyridinium sort of cation, and you can bring in another anion, you will have an ionic liquid. Similarly, over here you can bring in any other type of anion, that will be another ionic liquid. So this ionic liquid will be different from this one, because it's a 5-membered ring, 2 nitrogen, 6-membered ring, 1 nitrogen. So obviously we'll have a different stability, different property, different melting boiling points. Similarly, this will be 5-membered ring, but it's a saturated one, so its ionic liquids with any other anions, they are supposed to be having different sort of nature, different chemistry. Similarly, phosphorus substituted with other cations with alkynes. This is called phosphonium. Similarly, simply nitrogen substituted with 4 substituents having positive charge is supposed to be an ammonium. Similarly, there is another class that is called sulfonium. So this I've given you 4-5 different examples where the cations are the organic compounds. Cations are originated, have been produced from the organic compounds. So that is why they are organic cations, because in all the structures I've presented here, positive charge is there. In order to generate an ionic liquid, we have an idea we should have one cation and there will be another corresponding anion, and the mixture of the two will give us an ionic liquid. So this is how it is going to be. Let me give you an example of some anions. The anions also be organic as well as inorganic. Let me write inorganic first. I think it's observable. Inorganic anions, inorganic anions, they could be simple halides, chlorofluoro, iodo, something like that, or just given you BF4 minus, it could be an ion. It is called tetrafluoroborate. I've given you PF6 minus as well. Hexafluorophosphate, hexafluorophosphate. So these are the few of the examples of inorganic anions. As I've told you, the ionic liquids are supposed to carry the cations as well as anions. So we can have few of anions here. Let's say one can generate using imidazolium with chloride. This will be the one of the ionic liquid. Again, you can keep the same cation, use the fluoride, then number 3, then number 4. So you can generate 4 different ionic liquid using just by this one. Okay. Similarly, again you can use this pyridinium with all 4, 1, 2, 3, and then 4. Similarly, you can keep the same cation, but one can change the anions, something like that. So this is a variety of ionic liquids could be produced, the cations can be made to react, can be made to assemble with any anion, to give you a corresponding uh, ionic liquid. As they will have a different chemistries, they will have a different properties at the end, Similarly, we can have anions in the form of organics as well. Anions, I've given you example of anions which were actually the inorganics one. We can have the organics one, Let's say we can have alkyl sulfates. We can have alkyl sulfates. Alkyl sulfates having negative charges. We can have tosylates. It's something like that. We can have tosylate, something, yes, it could be CH3 over here. We can have something like that. It can be tosylate, It's a tosylate. It should supposed to be like this one. It's a tosylate. Over here, these are at least two examples of anions which are organic in nature. Mean your cations are also organic and your anions are also organic. So you can mix them together. Let's say this one and this one. Similarly, you can use pyridinium with alkyl sulfates or tosylates. You can have two more. Similarly, so chemistry, nature of the cations and anions, they are supposed to control the final properties of the ionic liquids, So this is how one can generate a variety of ionic liquids. I've given you examples, 4 or 5 different organic cations. Similarly, I've written 4 or 5 different inorganic anions, At the same time, your anion could also be an organic one. I've given you 2 examples, alkyl sulfonates and one can have tosylates, very famous organic compounds. So they could be used for the preparation of it should be oxygen carrying negative. In fact, they can be used for the preparation of ionic liquid. Similarly, you can have the tosylate with this one, tosylate with this one, or tosylate with this one, or you can have simply this body with this one with ammonium, or you can have with phosphonium, So this is a variety of ionic liquids. So a variety of ionic liquids mean a variety of solvents, ionic liquids with different chemistry, with a different boiling points, different range of temperature of their stability they can withstand, So this is how one can produce ionic liquids. What are the real mechanism behind that? Before going into the mechanism for the preparation of the ionic liquids, I should give you a glimpse about the applications of the ionic liquids, which are actually really attractive. That's why they are gaining application in almost all fields of science, Yes, the applications of ionic liquids, they could be, they could be used as solvents mainly. and in the form of solvent they could be used for reactions. Okay, as solvents, for synthesis I could write it organic synthesis. They could be used as catalysts, they have been used in many reactions as catalyst actually. They have been used solvents in many enzymatic reactions, mean the reactions which utilizes enzymes. They have been used in those reactions. They have been used in solvents where catalysts are used. They have been used as reactions, solvents for the synthesis. Secondly, they can be used as solvents for extraction. Extraction, you have an idea, I think, when we used to put our final product along with the solvent into this separatory funnel, and we put in some sort of organic liquid into it, and then we separated the organic phase separates from the water layer, aqueous layer, and this is we repeat the process 3 times, that is extraction, where we try to purify our product. So they could be used as solvents for extraction. Let's say for extraction we generally use organic solvents like dichloromethane, diethyl ether, ethyl acetate, methanol. This is how we use those solvents for the extraction, extraction of products, extraction for the purification. Over there, they could be used as solvent in place of dichloromethane, in place of methanols, in place of any other organic solvent. They could be used where they are suitable. They can be applied as solvents as well, instead of any other solvent. They have been used as electrolytes. They are being applied as electrolytes, electrolytes. Electrolytes in fuel cells. We have an idea about the fuel cells where they are used as electrolytes, They are used in solar cells as electrolytes because of the electrolytic stability. They are preferred, They are used in lithium-ion batteries. So this is about a brief sort of an introduction about their application. I'm just trying to give you a brief overview so that you can imagine their application, their scope of application, why they're important. They're important because they can be used as solvent for a synthesis. They can be used for the extraction of the product. They can be used for the enzymatic reaction. We have an idea enzymes are very sensitive to the solvents, to the environment. Means they are so effective that they can even execute the enzymatic reactions. Means all sort of solvent applications of solvents could be replaced with the use of the ionic liquids. Further, they have been, due to their electrostability, electrochemical nature, they have been used as electrolytes in fuel cells, solar cells, modern lithium-ion batteries. They are being used as capacitors. These are the few main stories, main examples where they have been used, They have been used for the preparation of functional materials. What the functional materials are, I think you people have a bit better idea. In case of functional materials, the ionic liquids have been used for the preparation of polymers, for the preparation of gels, They have been used for the preparation of lubricants. Similarly, they have been used for the preparation of ionic, uh, better to write liquid crystals. So these are the few of the examples, main categories actually, where they have found their applications due to their unique properties like their stability over a wide temperature range. Secondly, their uh, electrochemical stabilities, their thermostabilities have made them attractive entities for their application in many fields. And simply their preparation is so easy. I've told you the organic cations and the organic anions could be mixed together, or organic cations could be mixed with an inorganic anions. This is how we can prepare uh, ionic liquids, actually a range of ionic liquids with the different properties, different thermostabilities, different electrical properties. So they can be applied as per our desire, as per our choice. If whether we want to use them in the polymer synthesis, we want to use them in liquid crystals, or we want to use them in fuel cells, or you want to use them as solvents for reactions, or you want to use them as solvents for extraction purposes. So this is all about a brief overview about the ionic liquids, how they are produced, what is the chemistry preparation of ionic liquids, and their application. Preparation, yes, you can see preparation and application of ionic liquids. I will discuss it inshallah in my next lecture about the ionic liquids. Our next lecture will be in the same domain, in the same area. So ionic liquids preparation, synthesis, and their detailed application will be discussed inshallah in my next lecture. From today's lecture, if you do have any question, any comments, do come and you can put your questions in comment area. You can approach me through WhatsApp. I will be happy to respond at my earliest convenience. Please, thank you very much. Assalamu alaikum.